Hello everyone, welcome back. Today in this video, we are going to continue our conversation about exponential equation. In this video, we are going to look at a little bit different example compared to the videos we watched before. This time, instead of changing one side of equation, we are going to work on the two sides of the equation. In the past, we work on the example like we see the variable on two sides, but we just need to change one side in order to make the equation have the same base. That's what we did in the past. But today we are going to work on something. What if the changing one side is not sufficient to have the same base, to have the common base for two sides? Then we have to observe the number carefully and make the connection between the two numbers to see what changes we need to make for two sides in order to have common base. Okay, the method is still stay the same, is common base, but we need to explore more possibilities regarding how do we rewrite the both bases in order to be the same one. To get ready for that part, we are going to do a quick practice. We are going to look at the different group of numbers to see what numbers we can use to rewrite each group of number so they can have a same base. Let's quickly check that. So as you can see, we have 1, 2, 3, 4 groups of numbers. Each group, there is two numbers for us to use, but the idea is we are going to use the same base to rewrite each number. So the final part, the final result, we have a same base. So as you can see, 25 and 125, they do have a connection between 5, right? 25 is 5 to the second power, and 125 is 5 to the third. So that way, we can have a same base, 5. Next one. Of course, I cannot write 27 by using 9. I mean, you can use fraction exponent, but to make it easier, if you just think about the integer exponent, so it's easier to think that way, then we are going to think about one number. You can make a connection between these two. So 9 we can write as 3 squared, and 27 is 3 to the third power. So as you can see, now we have the same base as 3. Next, 18 and 16, as we mentioned before, you can always think about the fraction exponent, but it's a little bit complicated by just think straight with a whole number for the exponent. And we know this one is 2 to the third power because 2 times 2 times 2 is 8. And this one is 2 to the fourth. Again, by changing this way, we have a same base for 2. For next one, it's a little bit tricky because we are looking at a fraction, but as we said, it just represents the negative exponent, 2 to negative 2. And this one, as we said before, is 2 to the third power. So even we're dealing with negative exponent, but as you can see, we have same base. The reason you might wonder, why do we have to do this kind of practice? Because by doing this, you will be familiar, how do I use one number to make a connection between the two different bases? So that's actually referred to the type of equation we are going to work on, which is the one we need to change both sides. Let's check the example here. So as you can see, for 8 and 16, we know 8 times 2 is 16, but apparently you cannot rewrite 16 by using 8 if we prefer to use whole number for exponent. So this time we are going to work on both sides to change to have common base. So how do I do that? As we did before, number 8 is a connection to 2, which is 2 to the third power. So I just copied down this and this. And 16 is 1, is also connected to, which is 2 to the fourth power. So we know this. As you can see, now we have both is 2, so I'm going to simplify a little bit. So which is 2. Do not forget, when we distribute this one, we need to make sure everything is distributed. So 3 times 2x is 6x, 3 times 5 is 15, and this one, 4x here. And as we said, the most important part is same base, same exponent. So that way I can change the equation just by focusing on the equation, the exponent part. Since x is on one side, I just move this x here. Simplify this, is 15 equal to negative 2x, and we just divide by negative 2, and then we get the answer. Again, you can put a negative sign in front, on the bottom, on the top, really doesn't matter. But that's how we get the answer. So as you can see, instead of working on one side, we actually work on both sides. Okay, let's move on to the last example to reinforce our understanding by how do we use one number to change the both sides. So as you can see, this one, the two sides is 1 over 27 and it's 9. Again, if you have some idea or you really want to give it a try, you can pause the video to practice this question on your own. And just give it a hint. Do not forget 1 over something is always leading to a negative exponent. So I'm going to rewrite this one by using 3. And 3 to the negative 3 is going to be the answer for 1 over 27. And for the other one, we're still going to use 3 to the square, which is 9. So, and we just copy down what I will have left. So in that case, as you can see, we actually have same base. But simplify a little bit. We are going to multiply each part by distribute the exponents inside. So it is going to give us this accordingly. And now, like we said before, same base leading to same exponent. So now I can just focus on the exponents part, which is negative 12x plus 3 equal to 4x minus 2. So like I said, you can always move the number to one side, variable to the other side. So let's do this one. But some students, so we just solve this like a regular equation, and minus 4x for both sides, and then so we have 16x, negative 16x equal to plus 3 equal to negative 2. Some student was wondering, can I just, I don't want to deal with negative coefficient for the x, can I just plus 12x for the other side? Perfectly fine. That's what I said before. You can just use multiple ways to do whatever you need to do. The goal is to move x on one side, number to the opposite side. So since we have plus 3 here, we use inverse operation and we cancel this one. So we have this. Last step, this is negative 16 multiply the x. We're going to divide a negative 16 for both sides. It cancels, so x is going to be, because negative over negative is going to be 5 over 16, and that's it. There's nothing for us to simplify, so this will be the final answer. So this is just give us a example here regarding how do we change the both sides to be the same base, and then we use idea, same base, same exponent to solve the equation. Thank you so much for watching this video and study this topic with me. See you soon, everyone.